Today we're going to talk about solid geometry, section 10.1. We are introducing into chapter 10. Chapter 10 is all about 3 dimensions. So if you look up at the front of the board, we have the geometric solids there. Sphere, cube, pyramid, cylinder, cone, and prism. If you look back to the back left of the room, there are the other posters. Sphere, cube, rectangular solid, cone, and cylinder. Those are the formulas along with them for volume and surface area. And if you look over here on this side of the room, you get the three-dimensional figures there as well. Sphere, cone, cylinder, cone, or cube, sorry, prisms, and pyramid with the surface areas and volumes and some different details on them. So as we go through this chapter, those are going to be some important posters to take note of. All right, so solid geometry, section 10.1. First thing we're going to talk about is three-dimensional figures, or solids, can have flat or curved surfaces. Prisms and pyramids are named by the shapes of their bases. So for instance here, you can have what's called a triangular prism or a rectangular prism based on their base. You can also have a triangular pyramid or a rectangular pyramid based on their pyramid. Can I have a pentagonal pyramid? Yeah, I can have about any type of base I want to as a pyramid. Okay. Each flat surface is called a face. So every flat surface there is called a face. An edge is the segment where two faces intersect. Okay, so like that line right there, that is an edge. And then a vertex is the point where 3 or more faces intersect. In a cone, it is where the curved surface comes to a point. So notice right here, that is the vertex of the cone. It's the point, it's the tip of the cone. All right, so some examples of solids here. We have the prisms, a triangular prism and a rectangular prism based upon their bases. We have pyramids, triangular pyramid and a rectangular pyramid. We have a cylinder and we have a cone. Neither cylinder nor cones have edges. Recognize that. Neither cylinders nor cones have edges. That is important to note. Okay. Who can give me an example about one of each of these? Who can give me an example of like a prism? What's something that we use a prism? A what? What did you say? A can? A prism?
A wedge.
A block of cheese would be a prism. There we go. Great example. A block of trees. What? Yeah, like the big things of chocolate. That's a triangular prism. Nice job. A cylinder would be like a can. Is anybody here? Nope, nobody here has a soda pop this time.
Like those timers, like you put more slowly.
Hourglass?
Yeah. You get to half.
Maybe a type of cylinder, type of one. A cone. A lot of times, what's a popular cone? And ice cream cone. Okay. Those are some examples of the three-dimensional figures. All right. So the first thing here, try these 4. For examples 1 through 4, match the given parts of the figure to the names. So take a couple seconds, try these 4, match the given parts to their names. So number 1, which one would be the vertex? What do you say, Hannah? B, point T is the vertex. Nice job. What about an edge? Where's an edge at, Tom? D, segment PU. Get it? PU. 3, face. Which one is a face, Johnny?
PUT.
Yep, A, triangle PUT. And the base would then have to be what, Frosty? C, that's the bottom pentagon there. That's the base. So as I look at these first 5, I want to classify each figure. It says name the vertices, edges, and bases. Don't worry about that. We're just going to classify them, just get a feel for it. So number 5, what type of shape would that be, Noah?
Pyramid.
What type of pyramid, sir? That is a triangular pyramid. What about number 6? What do you got for number 6, Ryan? That is a cylinder. Number 7. What do you suppose for number 7? Caprio. That is a triangular prism. That's like just like your chocolate bar, man. Remember?
Yeah, but I thought the one, whatever the base is.
Pyramid goes to a point, a single point. Prism can be run along all the sides there. Okay? And 8, what do you suppose about number 8, Mr. Goldap? What about number 8?
What are we supposed to do? Just name them. It's like a cone.
That is a cone right there. Okay, hang on a sec, quiet down. Shh. So nice job. Take a couple seconds, try these two. Classify each figure, name the vertices, edges, and bases. Instead of naming them, I want you to label how many there are. So how many vertices, how many edges, and how many bases are there. So classify the figure, then say how many of each there are. Take a couple seconds, try these two on your own. Number 9 here. So classify each figure. What type of figure is number 9? Keegan, what is it? That is a cylinder. How many vertices does this cylinder have, Camden? How many edges does the does the cylinder have, Camden? How many bases does the cylinder have, Camden? 2. Number 10. What type of figure is that, Austin? That is a triangular prism.
How do you know if it's triangular or rectangular?
Quite cool if I play some.
Because it has triangles for its bases.
Oh, the bases?
The bases say it is. How many vertices does this have, Martina?
What?
How many vertices does number 10 have?
9?
Vertices.
Oh, 6.
How many edges?
9. Is that right? Is that wrong?
There are 9. Right?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. And then how many bases are there? Bases, not faces. How many bases are there, Troy? How many bases are there? There are 2 bases. Because the bases are my... Ooh, that's a bad one. The bases are my triangular regions. What'd you say? Yeah. Nice job. Okay, next part here. Quiet down, please. A net is a diagram of the surfaces of a 3-dimensional figure. It can be folded to form the 3-dimensional figure. The net at right has one rectangular face. The remaining faces are triangles, and so the net forms a rectangular pyramid. Because if you were to fold it across the rectangular base, it would all come up to a single point, making a rectangular pyramid. A cross-section is the intersection of a 3-dimensional figure and a plane. For example, the cross-section is what is the 2-dimensional figure if you were to cut it across right there. What would you see as a 2-dimensional figure? For instance here, the cross-section here would be a triangle. If I were to cut it across right there, I would get this triangular region that kind of is colored in there. So that would be a triangular cross-section. So cross-section is just what type of snapshot would you look at if you cut it right there at that certain point. Okay, to give you a 2-dimensional figure, what would that figure be? So let's look at 11 and 12. Describe the 3-dimensional figure that can be made from the given net. So number 11 here. What? No, I want the technical term here. What's the 3-dimensional figure number 11 would give us? Yes, Ryan. It would be a rectangular prism. Nice job.
Martina said box 2.
Yeah, you is it not?
That'd be rectangular
Box.
prism. And what about 12? Tom, what would 12 give me?
Triangular pyramid.
That is a triangular pyramid. Nice job. And again, triangular pyramid because here's my base. So it's a triangular base. And then they're forming up to a single point, making it a pyramid. Try these two. Take a couple seconds, try these two on your own. So number 13, what type of shape would 13 be?
Alright, that's one goal.
Kaylin, what'd you say? What type of prism? It would be a rectangular prism. Yep. If you were to fold it all the way around, it would give me a rectangular prism.
What?
And then there's 14. What type of figure would 14 get me, Max?
Rectangular pyramid.
That is a rectangular pyramid. Nice job.
Okay. Kicks me out.
Nice job. So those are the nets of these shapes. Now the cross sections. Again, this cross section is, if I were to slice it in half right here and look at it as a 2-dimensional figure, what would I look at it as? Okay, so what is the 2-dimensional figure that it cuts it up as? So describe each cross section. So if I take a piece of paper and slide it right down the middle of a can, Then you give that like a cylinder, right in the middle of a can. What figure, cross-section, two-dimensional figure do I see? Jersey? You see a rectangle right there.
What?
I see a rectangle. So I would draw it right there. Here's what I see. What's outlined in red? What's outlined in red is that two-dimensional figure I see. That is a rectangle. It gives me a half cylinder, but the cross-section gives me what looks like a rectangle. Nah. No dot parts, just that three-dimensional to help you out. So number 16, same idea here. If I take a piece of paper and I slice the cone up right there, and I look at this cross-section, what cross-section would my shape be, Ryan? That is a circle. Yeah, that right there would be a circle.
That's what I told Chase I'm looking at shapes.
So take a couple seconds, try number 17 and 18. So let's look at number 17. What's the cross-section going to be, Troy? That'd be a triangle right there. And what about number 18? What would my cross-section be on 18, Caprio? Yep, that would give me a rectangle right there. Nice job.
You like grabbing your nose and making it like this?
A little bit. Here's your assignment.